And hello, welcome to this video. So in the last video, I actually talked about how TCP connections attempt to help you get good data fidelity. So we want to recap a little bit on that. So remember, if we want to send a message called the quick brown fox jump over the lazy dog, okay, we will first need to break up the message and then label all the segments of words with some numbers, and then you kind of reassemble things back together. So that is part of usually how the TCP segmentation actually works. You can take a look at this link over here. So each TCP packet will have a segment number which you label so that you won't get garbled messages. Right, so that's one part of TCP. But the other part is also how you might have heard of this thing, or rather, okay, yeah, so never mind. I guess, easier way to talk about it is this. TCP in general, you'll have a lot of back and forth traffic. Okay, transmission control protocol. It will have a lot of back and forth traffic. You have maybe a few data packets here. Okay, a few data packets here which you break up, and then you kind of have to send it over. If you want to send it over, and let's say you have to label this one, you have to label this two, you have to label this three. Right, so hopefully when the other computer gets the message, they are able to reassemble things back together using the sequence numbers that they are given. I also said that, all right, let's say one of these segments gets garbled or corrupted, and you only receive segments 1 and 3. Okay, you only receive segments 1 and 3. How is the computer here supposed to know to send number 2 again? Okay, so I want to bring you to a sort of the way that TCP handles this kind of lost data packets. So I just want to make it very clear and explicit, because I think in the last video I wasn't very clear. Okay, so let's say you have segments 1, 2, and 3. Okay, then they are all supposed to be sent, right? Okay, so let's say you send segment 1. You send segment 1 over, and segment 1 is received over here. Okay, segment 1 is received here, and you kind of acknowledge it that okay, segment 1 is received. So how does computer A know that segment 1 is received? Okay, computer A knows segment 1 is received when computer B sends a message back saying that I received segment 1. So usually I'm not sending the whole segment 1 back. Okay, what computer B will send back is that yes, I received segment 1. This is called an acknowledgement message, also known as ACK for short. Okay, I acknowledge that I received segment 1. So that computer A knows that okay, I don't need to send segment 1 again. Okay, because by default, if I don't receive this acknowledgement message, or ACK message, they call it ACK message, then TCP will demand that A will keep sending segment 1 until B sends back an acknowledgement message, and then yes, there will be and segment 1 will be considered complete. Okay, so let's say you have this system, and segment number 2 doesn't get sent over properly. Okay, so what A will expect when it sends segment 2 over, okay, it will expect a message saying I acknowledge that you received segment 2 from B. Okay, so pardon the messiness. Okay, so if it does not receive this acknowledgement message within a certain time frame, it will keep sending segment 2 over until you get the acknowledgement. Okay, if I wait long enough and then I don't get any more acknowledgement, okay, maybe after a certain time, then there's a problem, right? So let's say your cable is broken. Okay, let's say your cable is broken. Then after some time, A does not receive any more acknowledgement packages. So A will think, okay, where's B? What is going on? I'm not receiving any acknowledgement packages from you, even though I keep sending these messages out. I keep sending these data segments out. Where is your acknowledgement? Okay, so after some time, when A keeps sending messages and spends, of course, computer resources and internet resources, your router traffic, I'm spending a lot of these resources to send messages, A will have to stop at some time. If not, it will just keep sending data perpetually, and that's not what we want. So there is a safeguard against this, and it's called a timeout. Okay, timeout, and this is usually what happens with connection. I mean, you have to terminate the connection. So this is called the no connection timeout. You can read about it here. Okay, so again, A will have to wait a certain time when it does not receive any acknowledgement from B, then the TCP connection is broken. So in fact, if you technically, in theory, if you actually unplug the wires between A and B, the Ethernet cable, and then quickly plug it back in, technically speaking, the TCP connection isn't broken, because the moment you because this connection hasn't timed out yet. So the TCP really relies on this sending back and forth of data, and if you don't receive the data back in time, you have a timeout and the connection is considered broken. And then if let's say the cable really breaks and you don't fix it in time, then the TCP connection will time out, and then A will stop sending messages across the TCP connection. All right, so that's usually how A will know whether to send these segments of messages or not. So important concept here for TCP. Okay, important concept for TCP. Okay, every data packet needs an ACK message. Okay, excuse me. Every data packet needs an acknowledgement message. Okay, it needs an acknowledgement message. All right. So okay, that is one concept that we need to cover in TCP. Okay, so hopefully that is useful. You will know what an acknowledgement message is. Okay, so let's try. Okay, let's again revisit our scenario where we have again computer A and computer B, or rather program A and program B, and program A is on computer A, program B is on computer B. Okay, so let's say we have the quick brown fox jumps over the wall. I'm going to assume it's broken up into 3 segments like this, 1, 2, and 3, and I want to send them over to computer B at some IP address, whatever. Okay, or some port number, whatever. So I want to send over these 3 packages. All right. So I want to send over these 3 packages to computer B. So I send over package 1, package 2, and package 3. Okay, let's say for instance the cable between them is broken, right? The cable between them is broken, and then of course A has a TCP timeout of maybe 72 seconds. Okay, that's usually okay, if you search TCP timeout, okay, for Windows, okay, it says here, what's the default TCP connection timeout in Windows? Okay, usually it's about 72 seconds, so that's where I got the number from. Okay, 72 seconds. Okay, so 72 seconds, right? So A will just keep sending messages 1, 2, and 3 over to B over these 72 seconds, and it will receive no acknowledgement reply. Okay, no acknowledgement reply. Okay, no ACK reply. Okay, so what happens here? Okay, I'll be sending package 1, 2, and 3 over and over again to B. I'm spending a lot of resources, programming resources, and I've kind of made the computer A work 72 seconds for no reason. Okay, and 72 seconds is a lot of time. Of course, if you have all your connections like that, you'll be wasting more than a minute just to try and send the message over, and there's no acknowledgement reply, right? So not only that, you're spending precious energy, precious resources trying to send over data packets that are never received. So how do you actually prevent this wasteful sending of messages? Okay, so we want to talk about establishing connections now. Okay, so you can see before, if we don't first of all, we want to make sure that B is in a state to receive all these packets, right? We want to say we want A to know whether B is ready to receive data. If it's not ready to receive data, why send the data in the first place, right? So for TCP, it's necessary for A to know whether B is okay to receive data. Very important concept. And so how is A supposed to know whether B is ready to receive data? Okay, so if not, of course you'll be sending all these messages and then nothing really happens, right? Because B is just not responding or the cable is broken, right? So how are you supposed to deal with this? Okay, so instead of sending all my data first, I want to know whether B is okay to receive data. And this is where we start to say we establish a TCP connection. Otherwise, you're wasting all your resources, sending all these messages over for no reason. Excuse me. And then you're wasting router traffic, wasting bandwidth. Yeah. So let's say we have computer A, and now computer A's job is to ascertain, or computer's A job is to make sure that B is able to receive my data packets. So instead of sending my data packets first, let me ask to connect to B. Ask B whether you are ready to receive my data. So the message we send is basically that. Okay, we send something called a SYN message, which is synchronized. Okay, so A says to B, hey, I want to send data to you. Okay, so let's synchronize together. Let's synchronize and form a TCP connection so that I don't send unnecessary data to you, and yeah, that is a waste of money or waste of time and energy. So so B will say, if B is working well and ready to receive data, B will send a message back called let's synchronize also, and that's one. I want to synchronize with you. Two, since for TCP, remember, important concept for TCP, every data packet needs an acknowledgement message. Okay, I will send an acknowledgement message along as well. Okay, I will acknowledge your first synchronization, and then I will say, yes, I want to synchronize with you also. So this is a SYN-ACK message. Okay, so B sends a message back saying these two actually are bundled together in one message, so it's considered one packet because these are very small bits of data. You don't need a lot of bytes to send a synchronized and acknowledgement message together. So A will say, okay, I need to know whether you are ready to receive data. Let's synchronize. And B will say, okay, I'll synchronize with you and I'll acknowledge your previous synchronization message. So they are bundled together. Okay, maybe to reduce the traffic. Okay, I don't know, but that's what they do. Okay, so B wants to synchronize with A, and B has acknowledged that A wants to synchronize with B. I receive your synchronization message. So what will A do? A will say, okay, remember, important concept in TCP, every data packet or every request will need an acknowledgement message. So A will say, okay, since you want to synchronize, I will acknowledge your synchronization. I'll acknowledge your synchronization. Okay, so A will send a synchronization message, B will send a synchronization acknowledgement message for this synchronization message, and it will also send a synchronization request back to A. Both of these will come packaged in one, and A will say, okay, since you want to synchronize with me, I'll acknowledge this synchronization message. And when this is done, we will say that the TCP connection has been established. Now this is also known as the three-way handshake. Okay, three-way handshake. All right. So this will say, this will help A to understand that, all right, my data is B, you are ready to receive data. Let me start sending those data packets over, like over here. All right. Okay. So this will say that, you know, A and B can start communicating or sending data to each other, or rather A wants to send data to B. That's more like it. All right. So this is establishing or opening a TCP connection. Okay. Now, since we talk about opening, how is this connection closed? All right. So let's say A and B have finished sending their data. So we have A, we have B here. Okay, and of course you can read about it in Geeks for Geeks and all this. It's data that's there online. All right. So how are we? Yeah. So once you finished, A has finished sending the message over. It has received all the acknowledgement flag for every single segment. Okay. Then A will say, okay, I want to finish the connection. I don't want to send any more data packets to you. So please, don't need to wait for me. You know, that's what A is going to say. So to terminate the connection, A will send a finish, FIN. We want to, I want to finish this connection, a fin message. Okay. Then B will say, I acknowledge that you want to finish your connection. So this acknowledge again is for fin. Okay, remember this principle for TCP, every data packet needs an acknowledgement message. So this acknowledgement message is for this fin. Okay, then once the B will also send a separate message this time, saying that, okay, I also want to finish the connection. Okay, B will send a message saying, I want to finish the connection, I want to terminate it, and A will send, okay, again an acknowledgement. Okay, A will send an acknowledgement message back. So for some reason, this acknowledgement and this finish doesn't, you know, come bundled together in one message. They are sent as two messages. For some reason, I'm not really sure why, but this is known as the four-way handshake. Okay, to finish TCP connections properly. All right. Okay, so this is the proper way to finish TCP connections. So, okay, so what happens? What happens in the scenario where, you know, connections are not finished properly? Okay. So, for example, we saw just now that there is a timeout. There's a timer basically for most TCP connections. So, okay, TCP connections can terminate prematurely. Okay, one because of timeout, right? Timeout. All right. So one cause of timeout, right? So okay. So remember we will have timeouts. Okay, timeouts. Okay, but let's visit some other scenarios where timeout may not. Where timeout may not be so, you know, timeout may not be the best idea for terminating TCP connections. Okay, so let's say you have a computer A and computer B. Okay, computer A and computer B. Alright, so again I want to send a message to that which has 3 components. Okay, a computer A and B hasn't they want to do I want to send a message to computer B, right? And usually to form a TCP connection, I want to send a SYN message first. Okay, because I don't want to waste all that resources sending unnecessary data packets over. Okay, so the A will actually wait for this acknowledgement. Okay, A will actually wait for, is expecting a SYN ACK reply after sending SYN ACK, because every message you send via TCP will have a SYN ACK, or rather acknowledgement reply. Okay, so A will be expecting this message back. Okay, the timeout period I'm not really sure, but if you don't receive a SYN ACK message within a certain time, maybe 72 seconds like for Windows, then A will say, okay, I don't want to wait for B anymore. I'm not going to send a message. I'm going to tell the user, there's something wrong with the connection. So this is one way, but A will be kept waiting for that amount of time, maybe 72 seconds, maybe longer, maybe shorter, but you are kind of waiting for that time. Okay, and timeouts actually work. I mean, if there's a worst case scenario that the cable breaks, okay, the cable breaks. Okay, let's say the cable doesn't break, right? Let's say there's a solid connection between A and B. All right, there's a solid connection between A and B, but for some reason your program is not working correctly. So while B is on and running and is connected to A, B's socket, or B at B, B is not ready to establish a TCP connection to receive this message. So so this is a scenario where the A is connected to computer B, but B is just not ready. Okay, I don't know for what reason, but it may not be ready. Okay, so when you send a SYN message over, okay, so what B can do, instead of what we can do, I guess as a sort of courtesy, instead of making A wait for 72 seconds, I will say, instead of waiting again 72 seconds, and instead of waiting 72 seconds, you don't want this to happen, right? So how to cut short that time? All right, I don't want to make A wait for 72 seconds. So instead of waiting 72 seconds for the timeout, B can actually send a message back saying, I'm not ready to receive data. And this is called the reset message. Reset message, RST. Okay, so you will see TCP connection termination. Okay, when some implementations need to close a TCP connection, they set a RST segment. Okay, so this RST is a connection reset, which means that whatever you're doing with your TCP, just shut it down. Kill the program, shut it down. So stop trying to send me messages. Okay, stop trying to send me messages. That's what this reset command is. So you can actually say, okay, I want to establish another connection on another port or something, I don't know. But reset messages basically mean stop sending me stuff. You need to shut down your connection. Okay, so you need to shut down this connection, and maybe you reset it, synchronize a new connection or something like that. Okay, and reset flags don't just have to be a response for a SYN request. Reset flags can be or reset messages can be sent back for any number of reasons. It can be sent back during this when you're sending messages over, if B somehow is not ready, okay, or crashed or something and then restarted, and then it's not in a state ready to receive your program data. So it will be this reset flag. and this reset flag will just shut down the TCP connection permanently it will just shut down the TCP connection, or this specific TCP connection is done for, and you don't need to go through the 4-way handshake to shut it down. Reset flag is an auto shutdown flag, and a reset flag means the TCP connection is done, and when the TCP connection is done, there's no need to send acknowledgement messages anymore. Okay, so every data packet needs an acknowledgement message, except for, I guess, acknowledgement messages itself, like this one. Okay, or reset flags. Reset flags turn off the TCP connection instantly. Okay, so one reason why reset flags are sent is because, you know, B is not in a good place to is not ready to receive data. Okay, one other reason is because there's such thing as a firewall. Okay, well, this is one other reason you can have a reset flag sent back to you. So if A is sending a synchronization request and then it meets this firewall, okay, this firewall can just send a reset. If it wants to block the connection, right, you can just send a reset flag back and it will terminate the TCP connection instantly. So that's one of the strategies a firewall can use. Okay, and you'll shut down TCP connections. One last but not least, another interesting reason TCP reset messages can be sent is because of malicious software. So if you look at Wikipedia, there's a whole article that's dedicated to this thing called TCP Reset Attack. And what happens is that, you know, if you have some hacker guy, I don't know, it's a hacker guy on the computer, and then you have a hacker laptop, and then, you know, this hacker can actually send a fake reset messages, and this is not because the computer B is unable to receive data from computer A. Is this hacker, for whatever reason, he or she wants to shut down your connection, and then it will send a fake. Okay, this is a fake. It's a fake reset test or fake reset, and I will send it to A to permanently terminate the TCP connection. So this is another reason your computer might receive a TCP reset, is because of TCP reset attacks. So in this way, the hacker has effectively denied you internet connection, or at least denied you from sending over your packets. Okay, so this is all right. This is one thing about TCP reset attacks, and apparently one of the prevention techniques, it says citation needed. So I don't even know. I guess cybersecurity. Yeah, there are some prevention techniques. I'm not going to go into that. It's beyond the scope. Yeah, but this is just some of the bits and bytes or nuts and bolts of a TCP connection. Okay, so hopefully this helps you to get a bigger picture of how TCP connections work, what some of the flags are, okay, and why some your TCP connections can terminate. So 2 is the RST flags or RST messages. Okay, so hope this video was helpful in understanding what TCP is about, how TCP operates to try and make sure your message is sent over properly. Okay, and why I introduced to you the three-way handshake, the 4-way handshake, and the reset flags. Okay, it's just to help you gain some understanding. Okay, so thanks for watching. I'll see you again. Bye bye.